Continuing with the notes. So that was relative extrema. Next topic we have to talk about is how do you find absolute extrema. So that's what we're going to talk about now. Finding absolute extrema on a closed and bounded set. Okay, step one is going to be the same as relative extrema. You are going to find the critical points in our region R. Here is where things change though. Critical points can also occur on the boundary. So step two is we are going to find all boundary points at which absolute extrema can occur. And then, kind of nice, kind of not, there's no fancy test to tell if it's an absolute max or a min. You are going to evaluate f of xy at all of your points. So this one, I will tell you, definitely requires more work. So just be prepared for that. So here's the example that we are going to do. Let's say that f of xy is equal to xy minus 2x. We are going to find the absolute max and min on R, which is the triangular region defined by 0, 0, 0, 4, and 4, 0. So here is what our R would look like. This region right here. Okay, so first step, we're going to start with those critical points. And these are the ones where f of x is equal to 0 and f of y is equal to 0. So if we take the first partial with respect to x, we're going to get y minus 2, and that has to be equal to 0. The first partial with respect to y is just x, and that has to be equal to 0. So the only critical point we get here is x is 0 and y is 2. But this point is not in R. It's on the boundary, but it's not in R. So because it is not in R, we don't consider it. Okay, so next thing that we consider is the boundary lines, or the boundaries. So we have to figure out what all of the boundary lines are. There are 3 in our case, 3 lines that define that triangle. There's the line x equals 0, the line y equals 0, and then if you trust me, that diagonal is the line y equals 4 minus x. So here's how that works. First, we approach along one of the lines. So I'm going to go along the line x equals 0. What we will do is we will go back to our function and plug in the line x equals 0. When we do, we get 0 minus 0. So that tells us that f of xy along that line is just 0. And now we're finding the critical points. So if I take the first partial with respect to x, I get 0. The first partial with respect to y, I get 0. So what that tells me is that there are no critical points on this boundary. Okay, if we go along y equals 0. Again, we are going back to this function. We are plugging in a 0 for y, so our function just becomes negative 2x. So our f of xy then becomes negative 2x. Our first partial with respect to x then is just negative 2. That partial will never be 0. So there are no critical points along this boundary as well. So then we go along y equals 4 minus x. So again, we're going back to our function. In place of y, we're putting 4 minus x. So we get f of xy is equal to x times 4 minus x minus 2x. So that would give us 4x minus x squared minus 2x, which simplifying is just negative x squared plus 2x. So our first partial then with respect to x is negative 2x plus 2. Our first partial with respect to y is just 0. That first partial with respect to x is equal to 0 when x is 1. So then our critical point along that line is 1, 3. The 3 I find from plugging 1 into the line. So this point has to be on the line. Okay. So far we have this one critical point that we found. In addition to that one critical point, you also have to consider all of the vertices. You with me so far? Okay. So here's where we're at now then. Now we are going to consider all of those critical points. And we need to plug them into our function. And if you remember, the function is xy minus 2x. So, first critical point that we need to consider is we have to consider all of the vertices. So that would be 0, 0, 0, 4, and 4, 0. And then the only critical point we found is 1, 3. Plugging all of those into f, I will tell you you're going to get 0, 0, negative 8, and 1. We are asked for the absolute maximum and the absolute minimum, which is the output value, not the point. So we would say that the absolute maximum is 1, and the absolute minimum is negative 8. That is how you find absolute. Now, of course, when you found maximum and minimums, you did word problems. So, of course, we're going to do some word problems. Questions on the absolute versus the relative. Okay, let's go on to a word problem then. We are going to find the dimensions of a box one that is open at the top, having a volume that is equal to 32 cubic feet, requiring the least amount of material. Okay, so we have some box like this, dimensions being x, y, z. If the volume is 32, we know that x times y times z has to be equal to 32. This is what we call a constraint. We also know that we're looking at the amount of material, which is going to be our surface area. So the base of the box is going to need x, y material. The side is going to be y times z, but there's two of them, so that's 2yz. The front is going to be x times y, but again, there's two of them, so there's 2xy. There's only, 2xz. There's only one xy because it's the bottom of the box, and we are told the top is open. So what you're going to do then, this constraint, you're going to solve for z. And you get z is equal to 32 over xy. So then you're going to plug that z into the equation that you have. So we get xy plus 64 over x plus 64 over y. This is the function that we are now trying to find the minimum for. So if we take the first partial with respect to x, we are going to get y minus 64 over x squared, which has to be equal to 0. If we take the first partial with respect to y, we're going to get x minus 64 over y squared, which has to be equal to 0. So this is the system then that we have to solve. That first equation gives us y is equal to 64 over x squared, which we're going to plug into our second equation. So our second equation then becomes x minus 64 times x squared over 64 squared equals 0. I just took the reciprocal of y since we're dividing by y. This becomes x minus x to the fourth over 64 is equal to 0. Factoring out an x, we get 1 minus x cubed over 64 is equal to 0. So that gives us x is equal to 0, or x is equal to 4. Okay, word problem, we don't care about x being equal to 0. We don't care about the box where the base is 0. So we care about x is equal to 4, rather. Okay, so then if we go back to here, if we plug x equals 4 in there, we get y to be 4 also. And then if we go back to here, up here, we can find z, and we get z to be 2. So ultimately, the box with the least amount of material is going to be 4 by 4 by 2. 4 is the length, 4 is the width, and 2 is the height. And remember, make sure you answer the question. The question asked us for the dimensions. It did not ask us for the amount of material. It just asked us for the dimensions. Now, of course, that is not a sufficient amount of work. The question is, how do we know This is a minimum. You would have to prove that to me. And you're going to prove that using the second partials test. Real quick, I'm going to show you what that looks like. S of xx you would need to find, which would be 128 over x cubed. S of yy you would need to find, which is also 128 over y cubed. And S of xy was 1. So then if you find d would be 128 over 4 cubed times 128 over 4 cubed minus 1 squared, which is 3. Again, I don't care about the value. What I care about is that it's positive. Positive value of d could be relative max or relative min. So then you look at sxx or syy. In our case, sxx, I will tell you, is positive, which tells us we have a relative min. Questions before we talk about the last thing? The last thing is very quick. You all just did 95% of what we needed to talk about. The last part is just a little bit. Okay. Last thing we need to talk about is using contour plots to find critical values. Or not critical values, critical points. So consider this example. We're going to look at 3 quick examples. For this first example, we can tell that there's a critical point at 0, 0. But we can't tell what kind. If we had more information about those level curves, then we would be able to tell if this is a relative max or a relative min. For something like this, I'm just going to do this very quickly without drawing in any other values. Are you okay if I just draw arrows without giving you numbers? Is anybody going to be upset if there are no numbers? This point right here is a saddle point. These 2 points right here are critical points. And one last one. I didn't draw those real great, but here we can tell that we have critical points at 0, 0 and 1, 0. this first one right here that has a value of 8 associated with it is going to be a relative minimum, whereas the one that has the 15 is going to be a relative maximum.